So since we now have decided that this can't be factored, the only way we can find the solutions is to graph it. So you pull up your calculator and you graph it. I'm going to make it big so we can see it better. Tell me what to type in since I can't see my paper.
X to the 4th, 6x squared.
Right, and we don't have to type in the equals 0 part. It's understood. Okay, so how many x-intercepts do we see? 4. 1, 2, 3, 4. And why exactly were there 4? It's degree 4. This is a quartic polynomial. So we were expecting 4 solutions. Now, 2 of those solutions are pretty easy to identify. Oops, I didn't mean to write that. Hold on. Okay, 2 of the solutions are pretty easy to identify. Right here, this one crosses right through at what location? -2. Over here, this one crosses through where? +2. So I can go ahead and write down -2 and +2. But these other places aren't so easy to identify. Like if you had to guess, what would you guess for that x-intercept? -1.3, okay, anything else? Okay, well, that's a good guess, but it's a teeny bit off. And like, what if your multiple choices on the test are like -1.2, -1.3, -1.4, -1.5? You're going to have a little trouble, correct? So there's a way where we can find out the exact location of the x-intercept. You hit second trace, and what's another word for x-intercept? 0. So you go down to 0, hit enter, or you could have just hit 2. And then see that blinking X? You're going to move it to the left side of the 0 that you're trying to find. So I'm moving. Okay, right now I went past it. Right now I've landed on the x-intercept. So if I go a little bit further, I'm below it, but aren't I also to the left of it? So I hit enter. Then it says to go to the right side of it. And once you're to the right side of it, you hit enter again. Once it says guess, you hit enter one last time. Where is it located? -1.4. Okay, so that's our third solution. But remember, we have one more, and you're going to find it the same way. It's located right here. You have to do second trace again. Second trace 0. Move all the way over. Okay, so right now I'm sitting on the intersection. So first I need to go a little bit to the left of it and hit enter. Then I need to go a little bit to the right of it and hit enter. And then once you've done that, you hit enter one more time. And where is it? +1.4. Okay? So does everybody now have a better understanding of how to do the second trace 0? With number 7, before we even graph it, how many x-intercepts are we expecting? 5, because it's degree 5. Does anybody remember the name for that? Quintic. Okay, so let's graph it. Y equals, y'all tell me what to type in. Well, the beginning I remembered was -1/2. You could type in -0.5 if you wanted. Or if you want to type in the fraction, remember you go to alpha y equals n/d. It's right there. Alpha y equals will take you to the fraction button. And then type in -1/2. And then type in the rest of it. X to the 5th. What comes after that? Okay, now, this one's kind of looking like it might be, pretty bad on the graph, right? But when you graph it, it actually turns out nice. Isn't every single x-intercept a whole number? So we're not even going to have to use second trace 0 for this one. Where is this first x-intercept? -4, then then, right? Correct. -4, -3, 0, 1, and 2. And remember, we were expecting 5 because it's degree 5. Now, one other thing that you need to remember about these numbers is they're not only the locations where the graph crosses the x-axis when the problem is set equal to 0. Like if I were to take the time to plug in a -4 into each x in this polynomial and typed all of that in, what would it equal? 0. If I typed in -3 in all of the x's, it would equal up to 0, or 0, or 1, or 2. That's why they're called zeros. Okay? All right, now let's look at number 8. Before we graph it, how many solutions, how many x-intercepts?
3.
Okay, so let's graph it. Y equals x cubed. Tell me the rest. Okay, but you don't have to type in the equal 0. Shh. Now remember, we said we're expecting 3 because it's cubic, but how many do we see? 1. And where is that 1? 5. Look. 1, 2, 3, 4, 5. So for this, we have one real solution. So the other two are imaginary. Okay? So our one real solution is at 5. The other two are imaginary solutions, which is what we're going to learn about today. We're going to figure out how to find out what those imaginary solutions equal. So now what I want you to do is I want you to turn to page 18. Okay, page 18. Okay, so it says, let's look at that number 8 from the Solve by Graphing Calculator worksheet. That's the one we were just looking at. Remember, this is what the graph looked like of it? We saw that there was one real solution located at +5. Now, if you write that one real solution as a factor, what will it look like? X minus 5. Because remember, when it's written as a factor, it's always the opposite sign. Okay, so, but we know that it's cubic, so there should be 3 solutions. So the other 2 are imaginary. We're about to learn how to find them. The first step to finding the imaginary solutions is to do polynomial division, which is what we learned yesterday. See how they have the original polynomial that we typed in to get this graph right here? And they've now divided it by x minus 5, which was the one real solution. If I'm going to do synthetic division on this, what goes in the little box? +5. And then what numbers go here? Right? Okay, then what is the first step in synthetic division? Drop down the 1. What do you do with that? Correct. 1 times 5 is 5. Then that becomes a 0. Multiply it by 5 and you get, then that becomes a, multiply it by 5 and you get a, and that becomes 0. So what's our remainder? 0. Now, remember from yesterday, if your original polynomial was cubic, then our answer is going to be quadratic. So you're going to have an x squared, an x, and a constant. Well, the 1 goes on the x squared. The 0, which we'll just put plus 0x, goes right there, and then plus 9. So, I know what you're all thinking. No, you don't have to write it like that. You would just write it as x squared plus 9. Okay, so now we have realized that the 2 factors for this polynomial are x minus 5, because that was the one real solution, and x squared plus 9. Now let me show you why those are the factors. Look at this. X times x squared is x cubed. X times 9 is 9x. -5 times x squared is -5x squared, and -5 times 9 is -45. Now, had I just shown you this, would you have known how to get it to the factors? No, that's why we needed synthetic division. Synthetic division allowed us to know the second factor. Okay, so now what we have is a sum of two squares. Aren't each of these perfect squares? Why is x squared a perfect square? How do you get an x squared? X times x. Why is 9 a perfect square? 3 times 3. That's why it's called a sum, because they're addition of two squares. Now, after I do this, you'll probably remember. When I factor a sum of two squares, what would need to go at the beginning of each one? An x, because x times x is x squared. What would go at the end? 3 times 3. And what about your signs? Okay, well look, if you make both of them positive, yes, it will produce a positive 9. But look, when you do your outer, you get a 3x. When you do your inner, you get a 3x. Are those going to cancel out to 0x? The only way to get them to cancel is what? Opposite signs. But then that poses a problem, because now that we have opposite signs, yeah, they'll cancel, because you have a negative 3x and a positive 3x. That would cancel. But is 3 times negative 3 going to produce that positive 9 that we're looking for? Who remembers what we have to put? I's. If you put an I here and an I here, and then you multiply those together, you get a I squared, which is a negative 1. And won't that negative 1 make that negative 9 become the positive 9 that we need? Okay, then, remember, whenever it's set equal to 0, you're not finished. You have to take each of the factors and set them equal to 0. Okay? So to solve this one for x, what do we do? Minus 3i. It'll cancel over here, and then over here, what's 0 minus 3i? Negative 3i. To solve this one for x, what do we do? Add 3i. And so x equals 3i. So that's two of our solutions, but you don't have to write them like that. You could write plus or minus 3i. I mean, you could write them separately, but more than likely on a multiple choice test, they're going to write it like that. What was our third solution? Those were our two imaginary. Remember, we had one real one at 5. So now we know our one real solution was at 5. That's the one we could see on the graph, but the two imaginary ones we couldn't see. One was at positive 3i, one was at negative 3i. Okay, now, has everybody finished copying that? I'm going to show you something. You'll probably be like, well, why didn't we just do it that way the first time? Well, you'll see. Just watch. Okay, you don't have to write this, because I'm sure you already wrote all this, so don't erase it. Just watch. Instead of factoring it like we did, because that was, I don't think it's complicated. It's harder for y'all to remember to do the x plus 3i, x minus 3i. There was an easier way to solve this type of problem. Anybody know where to start? Niall?
You start at 5.
No. You're on the right track. What do we do with that plus 9? Subtract it, and then subtract it to this side, and then you get x squared equals negative 9. Now what can we do to solve for x? To get rid of a square? Square root. Nothing, nonsense. Okay, then x equals, the square root of 9 is 3, but since it was negative, you put an I, and since we square rooted it, plus or minus. Well, isn't that what we got when we did the factoring way? But that's easier. But it'll be up to you which way you do it. It'll be whatever way you remember.
So we just...
Anytime you're dealing with a sum of two squares or a difference of two squares, you can solve it using the square root method.
Where did you get 5, the x minus 5?
Oh, because it crossed the axis at 5. Okay.
Or where it says x minus 5?
Oh, because remember, anytime it crosses the axis, when you write it in factored form, you write it's the opposite. So like if there were a point over here, you would write it as x plus 5. Okay, let's try the next one. Can I erase all that? Not yet? X cubed minus 8 equals 0. graph the polynomial and find the one solution on the graph. Okay, so first let's graph it. X cubed minus 8. Now, before we even see the graph, how many solutions should it have? 3, because it's cubic. But when we graph it, we only see 1. So the other 2 are imaginary. Where is the one real solution? 2. So as a factor, what would that be?
X minus 2.
X minus 2. You only care about the x-axis. Okay, so we just discovered that our one real solution is at 2. So that's one of our 3 solutions for this problem. But when you write that as a factor, you write it as x minus 2. So to find what we need, we're going to have to divide. To find the other factor, we're going to have to divide x cubed minus 8, which is the original polynomial, divided by its one x-intercept. So when we're doing synthetic division, what goes in the box? 2. What would go across here?
4. Negative 4.
I mean, oh, wait, no, 0.
0, 0, negative x.
Oh, because it's missing the X.
It's missing the x squared, and it's missing the x to the first. It jumped straight from the cube term to the constant. So we're missing 2 terms. So then we start synthetic division. So now we start synthetic division. Pay attention, guys. We're almost done. Everybody wake up. Okay, so look. You bring down the 1, multiply it by 2, and you get 2. Those add up to 2, which you then multiply by 2 to get 4. Those add up to 4, which you then multiply by the 2 to get 8, giving you a remainder of 0. Now, you have your numbers and a remainder of 0. If your original polynomial was cubic, what's your answer going to be?
Oh, square.
Squared, quadratic. So it's going to be 1x squared, which we don't really have to write the 1, plus 2x plus 4. So like look, this x minus 2 and this x squared plus 2x plus 4, if you multiply those, it would go back to x cubed minus 8. Okay? Now look, can we solve this with the square root method? No, the only time you can use square roots is when you're dealing with a sum of 2 squares or a difference of 2 squares. I mean, it doesn't have to be 2 squares. You just wouldn't end up with a whole number. But it has to be a binomial. You can only use square roots when the middle term is 0. And in this case, the middle term is not 0. So then, when you see something like that, your mind should immediately jump to bubble method. Can you, hold on. Can you find 2 numbers that multiply to 4 and add to 2? What are some numbers that multiply to 4?
2
Times 2, or 1 times 4. Is 2 plus 2, 2? Is 1 plus 4, 2? So this can't be factored. There's no numbers that will do that. Anytime you're dealing with a problem that can't be factored, you have to do what to solve it? Quadratic formula. So now that we see that x squared plus 2x plus 4 can't be factored, we have to do the quadratic formula. What's the very first thing you have to do the quadratic formula?
Set the
You got to identify your A, B, and C so that you'll know what to plug in where. What's your A?
1.
1. What's your B?
2.
And your C? Okay, so the formula's right over here, so tell me what to write. Negative 2.
Plus minus whole square root parentheses 2 minus 4 1
Right.
over 2 multiplied by 1.
Which is just 2. Right, there's no reason to write 2 times 1, it's just 2. Now, what's the next step to start simplifying this? Right, the discriminant, which is everything up under the square root. So type all that in. It was 2 squared minus 4 times 1 times 4.
Because you gotta put the answer in.
Well, I got to put the answer there.
Ding dong.
Okay, when you type that in, it simplifies to a negative 12. Okay, so then the next thing would be like, okay, well, what's the square root of 12? No, 6 times 6 is not 12.
We don't have a square root.
It's not a perfect square. See, it's a decimal. So we don't write it as a decimal though. What do we do instead?
We write it as an I.
Well, we are going to do that, but to simplify the square root of 12, forget about the negative right now. Just to simplify the square root of 12, what do? But it can be simplified. Can't you take it to the side and factor tree it?
Factor tree, yeah. Boy, come tree.
Okay, so circle,
Kill one.
get rid of 1, kick 1 out, and then the 3 was being good, so he gets to stay in the house. But like Niall was saying, since it's negative, you put an I. So now, instead of the square root of negative 12, I can just replace that with 2i square root 3. Okay, now if you'll remember, back when we first started learning about complex numbers, I told you that once you have a complex number, this 2, this 2, this 2.
No.
Very bottom corner.
Oh, because when we graphed it, we saw that the one real solution was at 2. Okay? Alright, so now look. Remember how I told y'all, once you realize you have a complex number, split it into 2 parts and actually break the denominator up for both parts? That way you can reduce it easier. Like what's negative 2 over 2? Negative 1. Plus or minus, what's 2 over 2? 1. I root 3. But when we write the final answer over here, what's not necessary? The 1 beside the I. So negative 1 plus or minus I root 3. So look, your first answer was real. It was 2. Your imaginary answers were negative 1 plus I root 3 and negative 1 minus I root 3. Because, like, it's technically 2 answers. Negative 1 plus all that and negative 1 minus all that. Okay, so if you'll turn to the next page, you'll see that there's actually 2 more examples. But we're going to save those for Monday because we're going to spend a second day on this since it's a little difficult. So that means the remainder of the class time today, you have plenty of time to look back at pages 13, 14, 15, 16, and 17 and make sure you're getting all of that done so that you're ready for next Thursday's 10 square. Now, page 15, you should definitely have done because we did it together. It was like the notes. But pages 13 and 14 were an assignment, and pages 16 and 17 were an assignment. While you're working on these, you can come up and check your answers with mine if you've done them, not just a copy. Or you can come up and ask for help on ones you're having trouble with. Do not just sit here and waste this time because then next Thursday you're going to be like, oh, I don't have this for the 10 square. Okay? So get busy.
Gotcha.